When I was asked by Teachers TV to teach a pair of maths masterclasses, I decided to tackle two topics that can be both tricky to teach and that students don't always see the wider point of. They're both topics that it's possible to have a lot of fun with, and I'm hoping that's what this group of Year 10 students from 3 North London schools will think too. What's the probability that your bus to school will be late tomorrow? What's the probability that David Beckham will walk into your life in the next 5 years? What's the probability that we'll have an earthquake tonight? What's the probability that I can juggle these 3 balls for 10 seconds without dropping them? Count. 1, 2, 3. 4, 5, been practicing. 6, come on. 7, Mum will be so proud. Oh. You know, life is a game of chance. And it's made up of a series of events that might either happen or they might not happen. What one thing is for sure is that we can use mathematics to help us make the right choices, to maximise our successes and to minimise failure. OK. Now then, ooh, these look nice. I'd like a volunteer, please. A volunteer. Look at my lovely doughnuts. Krishnan, up you come. Put your clipboard down. Excellent. OK. Choose one of my lovely, sugary, jammy doughnuts. Look good. Do they smell nice? Ooh, it makes you want to lick your lips, doesn't it? Lovely. Well, Christian's going to eat this without licking his lips. You think you can do it?
Definitely.
Without licking lips once?
Yes.
We've got to keep watching him. Who thinks it's likely that he's going to lick his lips? OK, you think it's likely. OK, then. After 3, 1, 2, 3, go for it. Watch him carefully. No licking. Watch him carefully. Oh, that's sugar. Watch him carefully. Watch him carefully. Oh, what's your name?
Mickey.
Oh, become quick. Take a donut. OK. What I'd like you to do is face each other. Take your donut. Right, you eat your donut too, but you can lick your lips and look at him. Lick your lips. Go on. It's like eating him. Lick your lips. Put him off. Go on. Lick your lips as much as you can. That's it. Oh, look at that tasty. Oh, look at those lips getting licked. Has he been practicing? Try and put him off. I think he's done really well. Give him a round of applause. You can lick your lips now. That is absolutely fantastic. Take a marshmallow. No, take a handful. Go on. Is it nice? It's lovely. OK, well done. Marshmallows. Excellent. OK, fantastic. That is actually a fantastic performance. Now, is it true that one person's actions there, OK, well, 2 people, because I was involved as well, was putting him off? We were licking our lips and trying to put him off. We were trying to increase the probability, weren't we, that he would lick his lips. We were influencing the probability, and therefore his chances weren't independent anymore. We were trying to affect his probability. Now, in life, there are things where we don't have such an influence, where we do have events that are truly independent. Coin tossing. Put your clipboards down. Come up and get a coin from me, a 50p coin. Up you come. I'd like you to choose a coin and find a space. We're going to do a bit of tossing. Choose one of my coins. Dahlia, excellent. We've all got a coin, everybody? Right, what we're going to do after 3 is toss our coin, flip it up in the air, catch it on our hand, try not to drop it, and have a look at what you get. OK, if you get a head, you've lost. I want you to take your coin and yourself and sit back down. If you get a tail, you can stay up, because tails never fails. OK, after 3. 1, 2, 3, toss! Catch! OK, what do we got? Heads, sit down. Tails, stay up. What have you got? Head, sit down, unlucky.
That's a tail.
Oh, yeah, it is. Of course it is. Tails. Tails, stay up. OK, tails, gather round. Gather round. How have we got now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. OK, we've got 8 people sat down. OK, toss 2 after 3. Same rules apply. The second toss. We're going to toss again. 1, 2, 3, toss. Tails never fails. If you get a head, sit down. Yes. Be honest, sit down. OK, that's 2 tosses. OK, let's everybody face the audience. Face the audience. Lovely. We have 5 contestants left. OK, toss 3. 1, 2, 3, toss. Flipping head. Get it? Flip. Tail. You've stayed in. Any heads? Sit down. Unlucky. 3 tosses. Good try. No, you can keep it. You can keep it. The 4th toss. The 4th toss. 1, 2, 3, toss. Tails never fails. How many have we tossed so far? 4. We've got 4 tails in a row. Wow. We could have a winner here. Toss 5. 1, 2, 3, toss. Leave it, let's see.
I've got a tail squad.
Tail again. 5 in a row. Do you think that's likely? No. Right, let's try for 6 in a row. Okay, 1, 2, 3, toss. Toss 6. Tails. Tails. Wow. Are you sure these coins are fair? Right, toss 7. 1, 2, 3, toss. Good flip now. Head, unlucky. Tails, we have a winner! Congratulations. I tell you what, that was pretty terrific, okay? 7 tosses in a row. Does anyone know what the probability of getting 7 tails in a row is? How are we going to work it out? Okay, we're having a think. What do you think, Arnold?
You do half times half.
You do a half times a half? A half
7.
times a half, isn't that a quarter?
No, to 7 times.
Right, why do you do a half times a half 7 times?
To get the probability of it.
Okay, right, you've got exactly the right idea. The first toss, let's break this down. The first toss is a half chance of getting a tail or a head, isn't it? So we write down the probability of getting a tail, 1 tail in a row. 1 tail in a row is, well, there's 2 equal likely outcomes, heads or tails. This looks like a tree diagram. Okay, the second toss, of course, gives us 4 equally likely outcomes. There's only 1 outcome that we want. Tail, tail. Okay, don't be a telltale. Right, the next toss, that's the third toss, gives us how many equally likely outcomes? Shout it out. 8 equally likely outcomes, and so on. So a half times a half times a half, and keep timesing by a half. Each time we're going to double our outcomes. 7 in a row is a half to the power 7. Who's worked that out? Half to the power 7. 1 over... Who said that? Edward. 1 over 128. That is quite amazing. You lucky person. 1 over 128. Where are you again, the lucky person? Where are you? Adam, it was amazing. Are you still stunned?
Yeah.
Come up here. You still got your coin? Put it in your pocket. Give it a magic rub. Okay, let's try 8 in a row. Go on.
Okay.
Go for it. A really good flip. Head. Unlucky. I thought you were on a winning streak as well. Right then, on the 8th toss, what was the chance of him getting a tail on that 1 toss?
1 in 200.
No, on that 1 toss. A half, okay? Because we've had an independent event followed by an independent event followed by another independent event, and so on. Past history does not influence it. Okay, 7 in a row is a half to the power of 7. Okay, what's the probability of getting n tails in a row? I'll start you off. A half. Mumina?
Half to the power of n.
Half to the power of n. Excellent. So 8 tails in a row. When n equals 8, what's the probability? Shout it out. 1 over.
8.
Okay, let's calculate it, okay? A half to the power of 8 is 1 over
256.
256. Good. A half to the power 8. Okay, I'll do the 1 over bit. A half to the power 9. 1 over... Quick, mental skills. 512. Good. A half to the power 10. 1 over... 1024. I wonder what the probability is that I'll get all those coins back off you, eh? Right then, let's move on to another interesting, very familiar situation. Here's a dice. 1, 2, 3, 4, 5, 6. How many equally likely outcomes on that dice, Meg? Okay. What's the probability that you throw a 1?
1 6.
Throw it. Are you feeling lucky?
Not really.
Woo! Oh my goodness! It's a 1. Well done, Meg. It was 1/6 chance, you lucky person. Okay. Right then, that's interesting. What's the probability that, just hold it there for a minute, if Meg throws it twice in a row she gets 2 ones. From the beginning again. 136. Good. So the probability she gets a 1 on her next go, of course, is 1/6. But she's already got the 1. So let's do another one. Would it be a 1/36 chance? It's not going to happen again, is it? Oh, unlucky. But the probability of getting a 1 followed by a 1 is 1/36. That is because, of course, we have 1/6 times 1/6, which is 1/36. 36 different ways that dice can land, okay, when I throw it twice. Let's take 2 dice. What's the probability that I get a double 1 on 1 throw? Why? Mikhail?
Because they're independent, so it doesn't matter if you do after each other.
Exactly, all together, simultaneously. 1/36. Fantastic. What's the probability of getting a double 6?
1/36.
Okay. More interesting question then, because you're a bit clever, yeah? What's the probability of getting a total score of 7?
That's quite a lot, because
Quite-
the different numbers make up 7.
What make up 7 then? Come on, do you want to write them up?
2 and 5.
Krishnan, do it. And write them on the board, yeah? Give you a fresh piece. The different numbers that make up 7. I love that. Krishnan got that just right. 1 and 6. That's one way. 2 and 5. Is he right? 3 plus 4. Is that it?
Yeah.
So there's 3 ways, yep. So the probability, yep, that's brilliant. 3 out of 36. Everyone happy?
Yeah.
Good, because I'm not. Oh, Anton, why aren't you happy?
Because it's not simplified.
Well, that's good, actually. Yeah, it would simplify to a 12th, but that's not the reason. Okay, let's look at it. A
You can
1,
do it the other way around.
a 1 and a 6. Yeah. Okay, you could get a 1 on that dice, a 6 on that, but you could also get, and this is another outcome, a 6 on that and a 1 on that. Okay, 2 different ways that give you the total of 7 using 6 and 1. So actually, the probability is, yeah, okay, which is in fact 1/6. What's more likely, getting a total score of 7 with 2 dice, or throwing a 4 with 1?
Same.
Equal, 1/6. Excellent, okay? And very interestingly, 7 is the most popular total. It's the most likely out of all the totals, and yet, key question, if I throw these 2 dice, am I likely to get a 7, even though it's the most likely? Am I actually likely to get it?
Depends what you classify likely as.
Okay, all right, well, likely is more than half chance. That's exactly what likely is. It's more than a half chance. Is it more than a half chance that I'm going to get a total of 7?
No.
It's not. So it's not going to happen. Never mind. Oh, it would have been nice if it did, yeah? But we can still say that 7 is the most likely score. Interesting. Do you know what the probability is, Edward, of winning the jackpot on the national lottery with 1 line of numbers, 1 line of 6 numbers?
It's like 1/1,000,000,000.
1/1,000,000,000. That's interesting. 1,000,000,000 to 1. Yeah, anyone else? You think it's... Does it what, sorry? Right, well, that's a very good, interesting response there. Does it depend on how many people are playing? Your payout depends on the number of winners, doesn't it? But forget the winners for the moment. Good point, and we'll come back to that. What's the probability that with 1 line of numbers, you get the 6 numbers and you are a winner?